Solve the separable differential equation given right here and find the particular solution satisfying the initial condition x of 0 is -5. You can see the answer. How'd they come up with this? Well, let's take a dx dt. I'll rewrite it down here is x squared plus 1/16. And let's multiply both sides by dt over 1. These will cancel, and we'll get dx equals x squared plus 1/16 dt. And then let's divide both sides by the x squared plus 1/16. Because we're getting all the x stuff together on one side and the t stuff on the other. So now we have, it's going to rewrite it this way, 1 over x squared plus 16 dx equals simply dt. So I separated it out, right? Got all the x stuff on one side, the t stuff in the other. That's what we mean by a separable differential equation. You can separate the x stuff from the t stuff. Sometimes they're so intertwined you can't separate them. We have to do other things when that happens. But this one, we can separate the x from the t. And now we just integrate both sides. We just say, okay, so the integral of this side and the integral of that side. And we're going to integrate. All right, so what becomes of it? Now, how do you integrate this left side? Well, we have a formula. And here it is from the notes. This is the Chapter 4 Introduction to Differential Equations notes I gave you. And it is right here. Basically, the derivative of this goes to that, so the integral of this goes back to that, right? So I guess I could put it this way. So derivative this way here. Let's go derivative this way, antiderivative or integral that way. So the antiderivative of that is that. That's what that means, right? It's saying the integral of 1 over x squared plus a squared dx must equal 1 over a inverse tangent of x over a, right? Because if the derivative of this is that, then the integral goes back. Derivative, integral are opposites. Okay, so the integral of x, let's bring that down. So we know that the formula says that the integral of 1 over x squared plus a squared dx is 1 over a inverse tangent x over a. Get that right, right? Inverse tangent of x over a, right? Okay, so there's the formula. I gave it to you to help out for this very problem. So this, oh, and I messed this up, didn't I? This should be 1/16, huh? Let's get that straight. 1/16, not 16. Okay. So that means our A, this is 1/4 squared. So that's our A. Our A is 1/4 squared. So what does it equal? It's going to equal 1 over 1/4, right? The A is on the bottom. The A is 1/4. A squared is 1/4 squared. So A is 1/4. Tangent inverse of x over 1/4. Again, the A is 1/4. So that means, flip it up, it's going to be 4, right? Flip this up to the top. 4 tangent inverse 4x. So that's what this is going to be right here. This is going to be 4 tangent inverse 4x equals, and what's the integral of dt? It's just 1 dt if you want. It's just going to be t. Plus, of course, we have a constant. Because whenever you integrate both sides, you have a constant. Does that make sense? So I used to integrate 1 over x squared plus 1/16. I use this formula, which is in the notes. The a is 1/4. So the a is 1/4. The a is 1/4. 1/4 on the bottom flips up to be 4. All right. So now I got to trying to solve here for x, trying to get x alone. So they're asking me to find x as a function of t. So divide by 4. Divide by 4. This is constant 1. We divide by 4. We have tangent inverse of 4x is 1/4 t. I'm gonna make my t capitalized, like them better that way. Plus, now constant 1 over 4, let's just call that constant 2. It's just another constant. Okay, so now what are we going to do to get this? Well, how do we get rid of tangent inverse? We take the tangent of both sides and tangent cancels tangent inverse. And we get 4x equals tangent of 1/4 t plus constant 2. And then multiply by a fourth on both sides. So x equals 1/4 tangent 1/4 t plus constant 2. But now, so there's that information. Now we're going to plug in the initial information. See what's right here. X of 0 is -5. So x of 0 is -5. So plug in 0 here for t. Tangent of 1/4 times 0 plus constant 2. Tangent of just constant 2, right? So multiply both sides by 4. Cancels that out. So we get minus 20, let's multiply there, is tangent constant 2. How do we finish getting constant 2 alone? Now we tangent inverse both sides. Just back and forth, and it's tangent inverse. Cancels out. Constant 2 is tangent inverse minus 20. Let's go find what that is. Tangent inverse minus 20. So let me see. I'll go to the Desmos stuff. Clear. Okay, tangent inverse. Go to functions. Go to tangent inverse. What was it minus 20? Now that's not the right answer. Why not? I'm in the wrong mode. See, I'm in degree mode. Always radian mode, unless they specifically say degrees. Back to radian mode. There it is. 1.5208. No, negative 1.5208. I'm in radian mode. Tangent inverse of -20. Negative 1.5208. Negative 1.5208. 208 is constant 2. So that means our function, which we had, where did we first have it? We had it right here. And so that means the function is x equals tangent of 1/4 t plus constant 2, which is minus 1.5208. So there's the function. Is that what they got? 1/4 tangent 1/4 t. Let's see. Yeah, they put the 4 in the bottom. Same thing as a 1/4 in the front. Tangent 1 t over 4, 1/4 t. Same thing. 1.5208. Yep, that's it. And that's how we do that problem.